So today we are picking up with day 2. So we are still looking at relations and functions. We are going to be able to determine if a relation is a function. You're going to be evaluating values of x on f, and you'll be using the vertical line test. So I apologize in advance. There is quite a bit of definitions that you have to copy down today. So the first definition is a function. A function is a relation in which each element of the domain is paired with exactly one element of the range. So a relation in which each element of the domain is paired with exactly one element of the range. Function notation says that f of x and then we have the vertical line test. The vertical line test says that if a vertical line passes through more than one point on a graph, the relation graph is not a function. We're introducing the term one-to-one. A function is deemed to be one-to-one if and only if every element of the domain pairs to a unique element of the range. So now if you are making a mapping, each arrow can only point to one number on the left and the right each one time. So it says determine whether each relation is a function. And then we're going to determine is that function one-to-one, which again, one-to-one says each element of the domain pairs to one element of the range, or is it onto, or both? So in that first example, 2 maps to 6, 3 maps to 6, 4 maps to 5, 7 maps to 8. So because each element of the domain pairs to only one element of the range, this is a function. However, my function is not 1-to-1 because 2 and 3 both map to 6. So it is not 1-to-1, but every number in the range maps to a domain, so it is onto. Number 9, 0 maps to 3 and to 7. Therefore, this is not a function because for every x, there is not a single y. X equals 0 goes to 2 values, therefore not a function. Number 10, it's also not a function because x equals -3 maps to 2 y's. If it's not a function, it's not 1-to-1 or onto. If it's not a function, it's not 1-to-1 or onto. Okay, use the vertical line test to determine whether the graph represents a function. So I can, in number 11, draw lines straight up and down, and every time I draw a line, it only hits the graph once. If that is the case, then this passes the vertical line test. If it passes the vertical line test, then it represents a function. If it represents a function, then we check to see if it's 1-to-1. This graph is not 1-to-1 because if I draw a horizontal line or a line straight across, it hits my graph at multiple points. If it hits the graph at multiple points, it is not 1-to-1. So in this case, this is a function, but it is not 1-to-1. It is, however, onto. Number 12 is not a function because it fails the vertical line test at many, many values of x. I can't draw a vertical line and only hit my graph once. Therefore, it is not a function. We start to graph equations. When we graph equations, we kind of just make a quick x and y table to get ourselves some points. I always like to plug in 0. So if I plug 0 into that function, I get 1/2 times 0, which is 0. 0 minus 3 is -3. So that point right there, 0, -3. We're going to talk in a day or two about that point. That point is called the y-intercept. So that should sound familiar from Algebra 1 and geometry. We know that this is in slope-intercept form, so that's my slope. If you don't know how to apply slope, which tells you up 1 and over 2, then what you could do is plug in some other values of x. Since that's a fraction of a half, I would plug in a 2, because 2 times a half gives 1. 1 minus 3 is -1. And again, I can see at x equals 2. I've plotted that point. at -2. A line is a special type of function. A line is a special type of function. We always draw arrows on our lines because our lines continue infinitely in both directions. Therefore, the domain and range of a line is always -infinity to infinity or all reals. The domain and range of a line is both always all reals. The domain and range of a line is always all reals. So at the beginning of this chapter in section 2.1's notes for day 1, I gave you the example where you had different functions and you had to plug in values for x. So this hasn't changed. We're still looking at different functions, plugging in values for x. What we're doing now is changing the notation. So f of -3 is the same as saying, I want you to plug in x equals -3 to f of x. So f of -3 is the same as saying plug in x equals -3 to the function f of x. So that would become f of -3 equals 3 times -3 minus 5. F of 0 would tell you to plug in 0 for every x. And f of 5 tells you to plug in 5 for every x. So it isn't changing the rules, it's just changing the notation. So 3 times -3 is -9. -9 minus 5 is -14. 3 times 0 is 0, minus 5 is -5. 3 times 5 is 15, minus 5 is 10. I always suggest showing this middle part here because on a test, if you type it into your calculator wrong and you don't show me that middle part and you get the wrong number, I can't allot you any partial credit. But if you show me that middle part and you get the wrong number, then I can give you points for plugging incorrectly but typing it in on a calculator incorrectly. We're going to find those same 3 points for each of the remaining functions. So again, every time you have the variable, you are replacing it with that number. Remember that when you multiply a number that is a whole number times a fraction, that you just multiply the tops and the bottom stays. So 3/4 times 5 is 15/4. Minus 1 is the same as subtracting 4/4. So that gives you 11/4. If you're using one of my calculators, a fraction on the graphing calculator is really just division. So 16, that's f of negative 3 equals negative 1/5 times negative 3 plus 3/5. So that's 3/5 plus 3/5. So these have common denominators. So 3/5 plus 3/5 is 6/5. When you have common denominators, you add the numerators. The denominator stays the same. F of 0 says negative 1/5 times 0. Well, anything times 0 is 0, so that cancels out. Plus 3/5. So f of 0 is 3/5. And f of 5 is equal to negative 1/5 times 5 plus 3/5. So that's negative 5/5 plus 3/5. So again, you add the tops, the bottom stays the same. Negative 5 plus 3 is negative 2/5. F of negative 3 is negative 3 squared plus 1. Remember, order of operations say you square before you multiply. So that's really like negative 1 times negative 3 times negative 3 plus 1. 3 negatives stay a negative. So that's really negative 9 plus 1, which is negative 8. Everybody sees the negative and they want to turn it to a positive, but that negative on the 3 is trapped by the square. So negative 3 squared is positive 9 times negative 1, giving that negative 9. F of 0, well, 0 squared still 0. 0 times negative 1 is 0. Plus 1 gives a positive 1. And again, you don't have to write the positive in front of the 1. It's just a 1. F of 5, it's negative 5 squared plus 1. So that's really negative 25 plus 1, which is a negative 24. If you're typing that in on your calculators, that 5 has to go in parentheses. Same thing, same rules, just absolute value now. So f of negative 3 equals the absolute value of 3 times negative 3. Remember, an absolute value acts as a parenthesis, so you have to clean up the operation inside first. So that's really like the absolute value of negative 9, which is 9. F of 0, well, 3 times 0 is 0. Absolute value of 0 is 0. F of 5, 3 times 5 is 15. Absolute value of 15 is 15. Okay, f of negative 3 equals 9 over 1 minus a minus 3. So you get 9 over 1 plus 3, which is 9/4. Because a minus does turn to a positive. F of 0 is 9 over 1 minus 0. Well, 1 minus 0 is the additive identity. So 1 minus 0 is the same as 1. 9 divided by 1 is the multiplicative identity, which says 9 divided by 1 is 9. F of 5. So you get 9 divided by 1 minus 5. Well, that's the same as 9 over negative 4, which if you don't like the negative in the denominator, that's the same as negative 9/4. That negative is fluid and can move up or down. I know you don't like to, but leave your answers as fractions. Leave your answers as fractions. Your homework is the next page in that note guide. You're doing 11 to 13 and 21 to 32.